What is in the app? Yeah, 5Q, another day, another kata. Create a regular expression that matches a word consistent only of letter X. No other letters will be used. The word has to have prime numbers of letters. Matching with re.match. Should match. Prime numbers of letters. Should match that. That. Should match. 2 is a prime number. 3 is a prime number. 5 is a prime number. 9 is a prime number. 9. And then it's 10, 11, 12, 13 is a prime number. 14, 15 is a prime number. And then 4 is not a prime number. 6 is not a prime number. Alright, your regex string should be only 40 characters. These tools may help you, which is a cheat sheet. It's basically like a how-to document, you know, but not for in general, for in general. And oh, this is the same window open twice, and this is online tester, which apparently like insert your regular expressions here and your test string here. For example, if we got 1, 2, 3, 4, 5, 6, 7, and here we can test it out apparently, and here we can't, I guess, test it out. So yeah, let's train that. It seems kind of hard, you know. It seems kind of hard because what do? We just test it out. Your regex should not match empty string, should not match that string. So let's say 2 is a prime number. Some of them should be, yeah. Alright, so what it needs to happen is for example, look. I have an kind of, yeah, the first idea that I get is to check that if we would have to check that there is even amount of x's, we would just say we put that into a group and say that can happen multiple or 0 times, and we would get always and we would have matched always the even amount of x's. But is there, I mean, there is not a rule, I guess, to the prime numbers, and that seems really hard. Let's just look at the comments. Inspected work, that should equal that. True should be resolved now. You have to declare again your valid and not valid list in the test cases part to be sure you won't mess them up. I remove valid and not valid. So these are just issues. Yes, keep some margin. Rebuild the code, golf check. I'm not sure this one is really interesting. That. Oh, I hope that isn't a solution. Solution has been withheld. Alright, fair. A little bit cheaty. What if I make code with restriction, let's say 20 to 30 characters? Then your code fails and you must start to think. Well, it's not cheaty at all in my opinion, since it really accomplished the test. The restriction could be a good way to enforce the thing. Yes, that won't be the same level at all though. I don't like hard-coded things. I like when people think with their brains. I don't want a light task. That solution is not remotely safe. Wow. Okay. So this is this guy who wants people to use their brains. Let's see. I wanna see who I am up against. It's from Venezia, but actually Munich. This is my web projects. My Code Wars progress. Ooh, nice. I could get something like that. Snake GitHub. Can we play Snake? Yeah, no Snake, I guess. Oh, is it? No. A game of life. Play. Seed. Clear. pause, play, step, clear. Yeah, that also doesn't seem to work. Play. Yeah, nothing seems to work. It's an interesting idea though. Oh, oh, what the fuck, he's senior consultant now. Well, I guess he doesn't need to maintain that. Alright, so to use our brain, how could we use our brain? So we got two links, this one and that one. And if you just look at these PostX classes, simple O, and for what thing? Oh, okay, for Python, great. Inline modifiers, none of these are supported JavaScript, right? On case insensitive mode, .all mode, look around, positive look ahead, negative look ahead, negative look behind, cat in, one cat. Munster. Where is Munster? That's also German, right? Ireland. Oh, I'm a noob. Character class operations, other syntax. The best RegEx trick ever, I have to click that. Okay. Wow, that is a very thoughtful and useful cheat sheet. Protected by copy escape. Why? Does that mean I can't copy paste? I can. I mean, say what? HTTP. Go. Okay. How to use tables, characters. So if I understand correctly, we must find a specific regular expression for prime number of x's, and the string and the expression must not be longer than 40 characters and nothing else. So if I say something like xxxxxxx, alright, that's around 40 characters, I guess. Is it gonna fail? It says, oh, well. Oh, so I guess the guy tried to implement the restriction but could not implement the restriction. Oh damn it, sorry. Alright, so I guess there is not a restriction of 40 characters, but yeah. So we can look right over here if there's anything that reminds us. So we say 1 digit from 0 to 9, 1 Unicode, so that just matches characters. We don't need any of that. Quantifiers, 1 or more, exactly 3 times, 2 to 4 times, 3 or more times, 0 or more times, once or more. More characters, any character except line break, a period, escapes a special character, logic, alternation, or capturing group, contents of group 1, contents of group 2, non-capturing group. That's some white space. And some quantifiers, the 1 or more is greedy. Makes quantifiers lazy. Okay, 0 or more is greedy, makes quantifiers lazy. What? So maybe here is something usable, you know, because the 1 or more, so we say that makes quantifier lazy, just first one. Although, okay, fair. That 0 or more is greedy. Yeah. Empty in 2 to 4 times greedy makes quantifier lazy. What? Oh, okay. That's some. I think that's not really usable. Characters in the printable section of ASCII table. Character classes. One of the characters in the brackets. One character that is not X. Anchors and boundary. Start of the string, end of the string, beginning word boundary, word not. Post X classes. Unicode letter. Function. Inline modifiers. Dot almost. Alright. Look-arounds. Character class operations. Other syntax. Keep out. Oh, that's for the best trick. Drop everything that was made so far for the overall image to be returned. As literal string useful to escape meta characters. Alright, what if we just do here prime? Python. It's not ready for prime time. Oh, okay, so we actually are on a good path if we just read this document. Because it mentions something of a prime number. Let's check it out. Prime. With RegEx, there's always more to learn, and there's always a more clever person than you, unless you're the lone guy sitting on top of the mountain. So I've often been exposed to awesome tricks that were out of my league. For instance, the famous RegEx to validate that the number is prime. In contrast, there isn't a drama the technique in this page. Anyone can learn it. It answers not one but several common and practical RegEx questions. These questions are ones that even competent RegEx coders often have trouble answering gracefully. It's simple to implement in most programming languages. It is easy to extend when requirements change. It's portable. Do I have your attention yet? Okay, let's go. I don't like, wow. That's a lot of stuff over here. Only, oh shit. Wow, yeah, I guess that's why the author used so much time in grabbing our attention, because we would need it for a really long time. Alright, so I guess there is a famous regex to validate the number is prime. So let's just Google that. Alright, so here we have So like for prime number, like can be divided by itself and x and 1. So the amount of x's should be such that it cannot be divided evenly. So it's like, could we try to divide the string with our regular expression pattern? Should match, should not match. Well, let's check out this solution. This is our test. Flavor Python 2.7. There is no Python 3 flavor, am I right? Let's say XX. Ah, okay, I see that it's really so let's see. XX. Alright. Now I don't really know how to approach this, if I'm honest. For prime numbers. In her. So we got a prolific Perl hacker, Abigail, is famous for posting enigmatic but ingenious one-liner scripts in her signatures and newsgroups. Here's one that blew my mind. Want prime if 1x shift and 1 1 1. Wow, okay. How could I do math? I couldn't rest until I figured it out, so here's how it works. Along with some obscure features of Perl and the hidden true nature of regular expressions. First, well, who is this prolific Perl hacker, Abigail? Perl hacker. The hacker known as 4chan. This is how it works. I'll explain things, but you should have a basic familiarity with Perl and regular expression before you start. Involved statement if condition. 1 1 1. Alright. A quirk of Perl syntax: a statement may have modifiers at the end like this. If condition statement. Alright. Shift normally removes the first element of an array and returns that element. I like popping from the beginning. Since we are in file scope, shift without array is magically interpreted to mean shift argu, which means the number we fed in as an argument. See perl.tf shift. X is the repetition operator. In this context, 1 is treated as a string 1. Yeah, if the number was 9, 1 times 9 yields 9 ones. Okay. The logical negation of will succeed if the RegEx does not match. Will match all non-primes. We will then make a string that is all ones as long as the number you gave us. So basically we are just reading a blog post on how to solve this kata. The thing is that there is just one less step, because we do not need to unpack x's, because we just have x's. You live in Texas, and that's why I hang my hat in Tennessee. Then we match that string against a complicated regular expression. If the expression doesn't match, print prime to the console. So, but here we want to make expression do match. Alright, the regular expression. Here's what the regular expression is saying, and it's like why slash matches beginning optional 1 ending, thus matches the empty string and 1. This matches the cases where n was 0 and n, and since it matches will fuck off. Or maybe I should rest my eye. Alright, so this is alright, or so it can be 1 or 0, or match beginning of the string begin first. Oh, so that is it can be 1 or beginning, it can be 1 1 plus question. Oh, I know something like this is used. This is used, you see? I knew it. Well, not this. Look, like Look Clan. It is right. It's right. Yeah. Where is it? Where is it? Where is it? Cat. Help me, cat. Cat is not helpful. It's over here. It's this one. Makes quantifiers lazy. This matches the first one. Oops. Where are we? Over here. So basically it just 1 and just 1, I guess. It can be multiple of them, but just match 1. And then this slash, I don't know what this slash does. One more multiple times, you know. So let's see. Match beginning of string. Begin first sorted group. Match a 1, then match 1 or more ones minimally. And sorting first group. Match the first group repeated. Match the first group repeated 1 or more times. The only reason why Abigail again generated a string of 1s was to make the regular expression confusing, since it also makes the use of first group. It could just been easily have been A or B. Oh, that Abigail. Anyway, let's follow along with the regular expression matching engine. The first big division in the regex occurs at the OR. This means the regex matches if everything before or everything later. First part. So let's look at the first part. It just deals with trivial cases where the number was 0 or 1. First, that in the regex will anchor the match to the start of the string. It can't match this anywhere in the middle. The next part is 1, an optional one, so it actually can match nothing. The next part of the regex is anchor end, which wants to match the end of the string, but our string doesn't end there, so it fails. Here is represented by red. Now what? Well, regular expression has failed, so it looks back to see if there are any other possibilities. That it hasn't tried it. It's called backtracking. It remembers that there was optional one. What happens if we try to match a real one? Okay, so it tries that one. Okay. Okay, so this is actually explaining the inner workings of regex. Alright, nope, that didn't work out. We see with trivial first part, if the string had been empty or 1, it could have worked out, and that corresponds in the case of n is 0 or n is 1. We've also seen how regular expression engine works. Yeah, if you gave it a specification like match.star_me, humans intuitively think about it as match, then some other stuff, then me. But regular expressions are actually descriptions of state machines. Wow, really? They are really a miniature programming language. You just happen to kind of look like the string they match. But they really describe a program for consuming a string piece by piece, looping over some bits, skipping over others, and even how to backtrack and try multiple options. The second part of RegEx exploits this state machine aspect of regular expressions to make them do computation. Yeah, these state machines are really nifty, you know, but not finite state machines, I guess just state machines. Yeah, we've been working with that, remember? With division by 5 of binary numbers and division by 3 with binary numbers. So I guess here you need to like make your own. Make your own. Yes. Yes. Second part. We start again by anchoring to the beginning of the string. 1, 1 plus question mark will match 2 1s at the start. Because these are in parentheses, this is a grouping. Because funny thing is that plus, I mean not the funny thing, you know, the thing that makes me wonder is that plus operator means get 1 or more, and question mark means 0 or 1. So I guess I don't really understand that combination, because these are in parentheses. This is a grouping. The value of what they match is captured into the back reference /1. Okay, I didn't know you can back reference it that quickly or have anything useful from that. That was a rat scare, you know. What happened? Alright, so that was actually a part for breakfast. Second part. Alright? Back reference 1 just means the first thing in parentheses. It doesn't have to do with literal 1 in the string. So we say it can be that 1, 1. Next, 1 plus matches 1 or more strings identical to the first matched grouping, which in this case is 1, 1. 1, 1, 1, 1, 1. Oops, but the string doesn't end there. We will have to backtrack. This doesn't work. So what? So I don't understand. So this is 1 or multiple. Okay, we have nothing left to backtrack to. How about 1, 1 plus question mark? Let's try matching 3 1s and calling that first. So 3. The end of the string is next. This matched. So you can see how this process is analogous to trying to divide a number. This is 4, 9, right? So you can see how this process is analogous to trying to divide a number by successively larger divisors, leaving no remainder. For n9 it tried 2 and that failed, and then 3 we succeeded, but in the case of a prime number this is never going to succeed. So like if we use that knowledge, that weird knowledge, you know, which matches minimum, we say first if like one thing that can happen is it can start or end them. So we got XX and then plus and then question mark, and then we back call 1 that can be 1 or more times. Is that right? Yeah, and a bunch of those tests pass. You are you or wow, that's okay. That's a little mistake over here in grammar. Should match 2 2. Uh-huh. So we can say likely so. Uh-huh. Not valid. Should not match. Uh-huh. Now it's matching stuff it should not match. But over here it is, oops. If we do that, what happens is, yeah, it's matching stuff that it should not match. Oh, so this thing to the rescue. Uh-huh. And then and. We forgot the and. So that should take care of some stuff. Whoops. Whoopsie daisy. Uh-huh. So we got bunch of should match and should not match. All right. Like, what if we just copy paste that and see what happens? Okay, it's completely, I think it's completely, it's flipped, because it should match prime numbers, but it matches non-prime numbers. And the thing that confuses me right now is this rule. Like, it says, yeah, like that happens and that couldn't happen if the number was not prime. No character that makes the match minimal, so to start trying to divide the number by 2, then 3, etc. It will reject 3 2 0 0 instantly, and it takes somewhat longer to determine that. That gives me an idea. Like, maybe we could try solving this kata with regular expressions. Why not? I get yeah, why not? So let's read this blog post. Is that like that super guy? Hacker, maker of things. Resign. Can take an iOS app that was authorized to run only on one developer's phone. And this is not a hacker on Apple security with implementing Python so I can use it even on Linux. What? Wow. I can't stand on most of the things now. I'm tormented by the knowledge that Rotten Bank is mostly run for the store packaging editors I don't need. An emoji-based stack language. Wow. Read on. That's a weird thing, man. Meow. Candle X, candle again. G. Candle Go car. Candle Go car. Okay. Some one-off hacks with graphics and UI. So that's Sauce Labs. Department. All offices. Remote. North America. What about Europe? No. Try it for free. Like, what do they do, Sauce Labs? So testing, I guess. Huh? What is this? Oh, so this is the guy. It's not the like the from the Incredibles. He's like, yeah. Cool picture, nevertheless. The 4K matrix. In order. Facebook allows programmers to look up a user by their account number. It's a very simple URL scheme. Early Facebook IDs aren't well known, so this is not a huge security issue. Or in the early days of Facebook, the ID was a simple auto-incrementing number. This leads to a hack which fits in a tweet. Early Facebook users in order. So I guess I could do a copy of that, paste it in my thingy, and I guess it doesn't work anymore, because it should print out the names, but it doesn't. See? So as long as you want. Who is Eduardo Severin? He's like angel investor. Okay. How is this site made? This is WordPress for sure. Octopress. Alright, so this is our thing. But the thing is right now that we only have to like switch it, I guess. Or let's see what we got here. Is this, and we paste that regular expression over here. It says that it matches some stuff but not the others. This is like 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 9. So now it matches 9, it matches 8, it matches shit. match 1, match 2. Yeah, it's not behaving as it's supposed to behave. Look, it's like 1 or more, 1 or more, 1 or more. Alternative to or asserts position at start of a line, and that's this thing, that's that thing. Yeah, so this thing, what it happens is also it matches some stuff that it should not match. What's the next prime number? If you just go like from 1 to 10, 1, oh shit, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It could be maybe easier done with copy paste. Just add 1, add 2, 3, 4, 5, and then that. So yeah, I do not understand this at all. Not at all. Match 9. Oh, so this is, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, it matches 9, right? Oh, so it matches every, like, oh, alright, I get it. So this thing matches everything that is not a prime number. Alright. What is Perl Hacker like? Copy link, add address, and you go over here. You say Wayback Machine. Like, yeah, as you can see, I'm doing all the other stuff but solving this kata. Shit. This is 2000. Oh my god, this was posted like 22 years ago. Oh wow, wow, wow. On snapshot, let's see how this website look like. My GitHub. Perl musings. Like, a lot of people are like Perl musings. Earth. Wow. This is the machine over here. November. Hey, you remember 21st of September. It's 2007. Let's look at this site on 2007. Oh yeah. Tuk 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 tuk. I like how it's also seconds included. Alright, so this site has been always kind of minimalistic. Our hikes for locals only. My Perl pages. Junk mail statistics. Movies I rated. Movies. HTML. Oh, okay. Wow. Lord of the Rings, that's Poet Society. Troy. Harry Potter, Malcolm X. The worst is heavy metal. Pulp Fiction is none better. Ha, nice. I like Nicola. That's pretty lame. Well, that's. Okay. So yeah, it says like return like that matches non-prime numbers. So it's kind of a reverse Boolean thing over here. So we just need to find a way to reverse that. So it can be divided by itself and 1. Yeah, that's just trash at this point. We can use caret as anything but that. So you can say that. No. Everything but that. Like. Can do. Test, like test, you know. Maybe if we add one more x here, maybe that shall solve it. Yeah, it doesn't. But it's closer. Should match. Yeah, and if warrior regex match word is none, this file should not match. Format length regex. Oh, so it just looks at length. Oh, so it also has like 40 lines, 40 characters. No, 40 characters or 40 lines. So your regex. So if we just like add stuff in the end. That's 40 for sure. Okay. And it's actually passing. Yeah. Alright. How do we invert that? We can actually like learn a lot just by inverting it. Should match too. Should not match. So first we can just should we delete the first part? Or should we say like return none if like this is the case? Shit. Should this be like negative look ahead assertion question mark exclamation point? Oh, okay, we got it. Okay, your match differs from expected work that Oh, so now it's looking for matches because we actually need to match it. Maybe we just do like, if that is filled but access can be 0 or multiple, still passes. Should not match that. Spaces. Okay, so we say, so you got that non-empty spaces, fully random words. Regular expressions should not match this. But it doesn't match it. Because it's only X, right? Test passes. Like it doesn't match it, man. Only X. Multiple times and that's the end. Yeah. Yeah, I have passed all the tests. Even if I like cancel this, I'll still pass all the tests. Alright, so yeah, we can submit that and say, yeah, we have we have successfully inverted it, you know. That's a good thing, although I still feel kind of not good because I don't really understand this. Like, what's the logic? Even here, I think even this guy doesn't understand it that well, because it says second part, like we start that, it matches that, but the string doesn't end there, we have to backtrack, this doesn't work. Okay, we have that, and so we can end the string is next, this is matched. So you can see how this process is analogous to trying to divide a number by successfully larger divisors, leaving no remainder. Alright, so this guy does understand it. Alright, I'm sorry. Nilk. For n9 he tried 2 and that failed, and then which succeeded. Yeah, because 9 is not a prime number. Yeah, forgot that. I had in my mind like 9 is a prime number, so that kind of threw me off. But in the case of prime number, this is never going to succeed. Alright, yeah, so this like last paragraph is key. So what is this code trying to do? Is it saying 1 or 2? It can be 2, and it's like all the prime numbers. Alright, so it's saying it can be like 2, you're building from 2 and then you're incrementing by 1, like 3, 4, 5, 6, and then you just 1 times multiple. Alright, now I get it. So let's submit that with a little more peace of our mind. And we basically get so this is also like fail it if this happens. And this is XX, and X can be 1 or multiple. 1 or multiple. Alright, so I guess that question mark wasn't really necessary, right? Much more efficient with the inclusion of a single character. If that were not included, the RegEx would immediately match the entire string at 1 plus. Okay. So I guess regular shit. Shit. Oh no, I started to close it. Alright. And this one, alright, so I guess this is slower solution, I guess. And so so don't take that, but take that. But all of them use like this. They use the first group. They call the first group back. Alright, so that's for today's cut. It was interesting journey and all, and thank you for watching. Have a good one.